So very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveli Talent Schools and the Mastermind Schools. So once again, I welcome class 9 students of all the participant branches for today's session. As you all can see on the screen and you are well aware, my subject is physics. We are in class 9, our ongoing chapter gravitation, and today we are entering into the session number 3. So far we completed the 2 sessions in understanding the concepts of gravitation. Still it will take maybe 2 to 3 sessions to complete the entire chapter, which is the syllabus for upcoming test 6, which is on 30th December, right? So you have to focus more on the gravitation part for next 2 sessions, that is next week, and the entire syllabus will cover in this particular test number 6. So we'll continue where we stopped in the last class, but before that, just we recall what we learned so far. So if I tell you, so we learn about what is the gravitational force first, that is after the observation of Isaac Newton. Then we learn about the universal gravitational constant, universal law of gravitation by Newton. F is equal to G into m1 m2 by r square. Then we learn about the gravitational constant, that is capital G, which is constant everywhere, any universe, whose value is 6.67 into 10 power minus 11 Newton meter square by kg square. Then yesterday we learned about the acceleration due to gravity. Very important again. Acceleration due to gravity, that is small g. And we know that is small g value check. Capital G value is constant anywhere in the universe, but small g value varies with the height, with the depth, with the place, and it also changes the planet to planet. As we already seen, on surface of the earth, it value is 9.8, whereas when you go to the moon, it value 6 times less than the earth, that is 1.67. When you can go to sun, we cannot go, only imagination, it is 27.3, which is calculated from mathematically from the formula, the relation G is equal to Gm by r square. From this formula, you can find out the G value of either earth, moon, sun, Jupiter, Mars, or any other bodies, if you know the value of their mass and radius, right? So these all things we learned in the earlier classes, the last class. So we'll go for some more information about the gravitation and its effect before concluding the today's session, right? Now we'll move forward. So these are things what we learn. Apple tree. Why, how is the questions raised by the Newton when he sat under the apple tree, which leads for the discovery of gravitational force, right? So this is the gravitational law. F is equal to G into m1 m2 by r square, or G into m by r square is the Newton's law of gravitation, or it is also called universal law of gravitation by Newton, right? So that afterwards you can find, after deriving the formula, is also explained about the what is the capital G, the universal gravitational constant, whose value is given by 6.67 in 10 power minus 11. Same case, same time you can find out what is the gravitational force between the two bodies, that is on sun and earth, moon and earth, and body and earth. All the 3 cases we found out the gravitational force value when the body of mass small m is placed on the above the ground, above the earth, we got 9.8 Newton. Between sun and earth, we get the huge number, that is 3.6 into 10 power 22 Newton. Between moon and earth, it is given by the 2.05 to 10 power 20 Newton, which is found from the formula F is equal to G into M1 M2 by R square. Then when I enter the synopsis 2, which we discussed yesterday, we learn about what is acceleration due to gravity. That is, the acceleration produced in a freely falling body due to the gravitational pull of the earth. Due to gravitational pull of the earth is called acceleration due to gravity, right? Gravitational pull of the earth is called acceleration due to gravity. So whenever you are throwing a body, dropping a body or throwing a body, so it is comes down or with a acceleration from 0 to some acceleration. That is because of the gravitational pull. That acceleration is called acceleration due to gravity, which is denoted by small g. Denoted by small g, right? Whose value varies from place to place. That we have seen in the last class. Expression also we have seen G is equal to Gm by R square. From that, you can get the G value also on Earth as 9.8 meter per second square. On Moon, it is 1.67. On Sun, it is. So, this value, when you go to the above the surface of the Earth or below the surface of the Earth, the value of G changes, decreases, which can be observed with the formula, same formula. The same formula you can use and find out how the value of G decreases when you go to the above the surface of the earth. As you are going to the height, the value of G decreases 9.8 to 9.7978 like that. But when you get to the depth, when you reach to the equator, on poles, the G value is maximum. At poles, G value is 9.8. But when you reach the equator, the value becomes 0. Means it becomes 9.8 to 0 means the value decreases gradually. So when you go to the radius, entire radius of the earth, 6.4 into 10 power 6 meters, then the value of G becomes 0 also. That clearly indicates that the value of G decreases with height, decreases with depth also. Right? Height and depth both will influence the value of G. Right? Then variation of value with altitude. When you go to the height, already I showed yesterday, as depth below the earth crust, when you go down also, the value decreases. See, when you go to height, you can check by simple way. How you can say it is decreases? For example, the general on earth is given by Gm by R square, right? G is equal to Gme by Re square. Earth in terms of earth I wrote initially. So suppose say this is the earth, globe. So this is the surface. From though this is the radius. From here we kept one object here. Object at a height of h from the surface of the earth. Some height. Right? That is h. So then what happened? G what G is this is okay, say this is G or E will take this. This is G, this is GE. G ME by in place of R we can write what? R plus H. Because it is a height. When on the surface you take only R only, but at the height of H, say consider GH. Sorry, you can take GE, GH without confusion. Okay, at the height of H. Okay, mass won't change anyway. So in place of R, we can write R plus H whole square. R plus H whole square. Right? So when you divide these two, divide 1 by 2. GM cancel because mass is same, G value is same. So what it becomes here? It becomes GH by GE if you take this by this. We'll get R by R plus H whole square because R square by R plus H will get R by. So what does this indicate? Numerator is more. So numerator is less, R only. But denominator is R plus something. R plus something means whole square. Means definitely denominator is greater than the numerator. So when denominator is greater than numerator, what it indicates? Value is decreasing. Decreasing of value can be seen. GH is equal to GE into something. R by R plus H whole square. So it clearly indicates that GH is less than the GE. So as you are going to the height, the the value of G decreases. Similarly, you can take depth also. In place of H here, minus you get. That's all. Minus, because you are going deep into the earth plus. So, but that you can get this one. 1 minus d by r into G, original one. Right? So, like that in both cases, either you are going to the from the surface to certain height or from surface to depth also, the value of G decreases. But finally, what you observe is at poles, very important point is the value of G is maximum at poles. Right? G value is maximum at poles and minimum at equator or zero at equator. So G at poles is maximum and G at equator is minimum. This is a very important value. And G value even minimum or even zero also on equator. On G on surface of the earth is 9.8 meter per second square. So when you go to the depth, height, G value decreases. When you go to the depth, GD, G value decreases. Both cases, G value decreases. Right? So when you travel to the depth of 6.4 into 10 power 6 meters, even G value becomes zero also. When you touch the equator, at equator, the value of G is zero. Clear? So now we are clear about the total about the gravitational force. So at poles and equator also given here. Right? At poles, what is the value? At equator, what is the value? So earth is not a perfect square. It is bulged at equator and flattened at poles. Hence, R at equator is more than the R at poles. Right? R radius. R is not radius. See here, clearly mentioned. As the radius is more, automatically the G value decreases. You can find the elliptical like this. So on equator, it is bulge. So radius is more compared to the poles. So that is the reason G is directly inversely proportional to 1 by R square. So G value decreases with radius. More radius, less G value. Less radius, more G value. So as equator G, radius is more, the value of G is less. That is the relation indicates here. So G is maximum at poles and minimum at equator. Clear? Very, very, very important bit to note or point to note here. Then, so another commonly used words we have discussed, very interesting it is to discuss about both mass and weight. Commonly in our regular terms, we feel that both are same only. But there is a big difference between the mass and weight as physics point of view. Okay. So before going further, I'll show you one video about the mass and weight and gravitation. Then we'll move to the differences and what is mass, what is weight. We'll discuss in the after this video. Right.
On your bathroom scales, what are you actually measuring? Well, if you said weight, like most people would, then you're sort of wrong. Kilograms are a measure of mass, but the scales actually measure the force of gravity on your mass. So they do actually measure weight, but this should be in units of force, newtons. Confused? Keep watching. This is a 1 kilogram bag of sugar. Grams and kilograms are units of mass. Mass is a measure of how much stuff is in something. This bag contains twice as much stuff. It has a mass of 2 kilograms. It would be wrong to say the bag weighed 1 kilogram or 2 kilograms, as weight is a force caused by gravity. To measure the weight, we need a spring balance or force meter. This is a force meter, or a Newton meter. It shows the weight of something hung from it. Let's add the bag of sugar. It shows the weight is almost 10 newtons. Can you remember the equation that links mass with weight? Remember F equals ma, where F is force in newtons, m is mass in kilograms, and a is acceleration in meters per second. We can rewrite this a little as W equals mg, where W is weight in newtons and g is acceleration due to gravity. On Earth, g equals 9.8 meters per second per second. So the weight of the 1 kilogram bag of sugar is 1 times 9.8, which equals 9.8 newtons, as the picture shows. Often in everyday life, we use the word weight, when in fact we mean mass. The bag of sugar has a mass of 1 kilogram, but a weight of 9.8 newtons.
See the difference?
Now let's take this bag of sugar to the moon. The moon is much less massive than the Earth, and so has a lower gravity. On the moon, g is only 1.6 meters per second per second. See how the weight has dropped compared to when it was on Earth? But notice,
So 9.8 Newton become 1.6 Newton. Weight, when you go to the moon, 1 kg sugar becomes 1.6 Newton only. 6 times it actually reduces. Okay.
we still have the same amount of sugar. There is still 1 kilogram of stuff. The weight has changed, but not the mass.
Mass same.
Jupiter, the gas giant, has a G value of 25.
In case of Jupiter, 25 meter per second square. Almost equal to the Sun. Sun is 27.4. Jupiter G value is, you can note, is very important. 25 meter per second, which is 3 times more than the Earth G value.
5 meters per second per second. Can you work out what the force meter would show for the bag of sugar here, assuming there was a solid surface to stand on?
25 Newton.
The sugar now has a weight of 25 newtons.
But mass
But
same.
don't forget, we still have 1 kilogram of sugar. That hasn't changed. Do you remember gravity? Watch this video. An object thrown away from the Earth will experience a force towards the Earth which slows it down, stops it, and the object accelerates back towards the Earth. This acceleration is due to the Earth's gravitational force and is written as a little g. It's also known as the gravitational field strength. To stop the apple falling, so to prevent the gravitational force pulling it towards the center of the Earth, a force is needed that is equal to this gravitational pull. Remember this. And on Earth, g equals 9.81 meters per second, or approximately 10 meters per second. Okay, back to mass and weight. Remember that mass is a measure of the amount of stuff in an object and gives a measure of how difficult it is to get moving or to stop it. It never changes. For example, my mass on Earth is 56 kilograms. On the moon, I would still have a mass of 56 kilograms. The acceleration due to the Earth's gravity is measured in meters per second, or it can be measured in newtons per kilogram, as it's a force exerted on a unit mass. So let's now use this lovely equation to find my weight. Weight is the force due to gravity, and that depends upon the masses of the two objects that are attracted. On Earth, my weight is mass times gravity, so roughly 56 kilograms times 10, which is 560 newtons. But what about on the moon? The gravitational acceleration on the moon is only 1.6 meters per second. I hope you got 89.6 newtons. So, you would feel very light on the moon, and if you try to walk,
You yourself feel very
each
light.
step would send you leaping away from the surface. See how gravitational field strength changes on the surface of different planets. This is because the planets have different sizes and masses. The largest planet, Jupiter, with the greatest mass, has the highest gravitational field strength. My weight on Jupiter, if there was a solid surface to stand on,
14
would be
Newton.
1,400 newtons. And bathroom scales, which are calibrated in kilograms, would show I had a mass of 143 kilograms. You would feel very heavy, yet your mass would still be 56 kilograms. Just your weight would be 2.5 times more than on Earth. Now for Newton's apple. An apple with a mass of 100 grams is held in your
Wherever you
hand
go, you can
to
find
stop it
Newton's
from
apple.
falling to Earth. What force do I need to prevent it from starting to fall? Take the acceleration due to gravity to be 10 meters per second. Pause the video and work this out. So the force is mass, m, times g, or 0.1 kilograms times 10. So the force of gravity on an apple is about 1 Newton. And it was the falling apple that gave Isaac Newton the idea in the first place. How about that? And just remember, our mass always stays the same,
Yes.
but our weight can change.
That's all. So this is a clear explanation about the mass and weight, which we're going to see now. Mass and weight both are sound same, but there is a big difference between these two. So mass is the quantity of matter contained in a body. How much quantity matter is having, right? Suppose you have 1 kg of sugar. The mass of the sugar is 1 kg on Earth. You take to the moon also, it is 1 kg only. You take to the Jupiter also 1 kg only. Wherever you take, the mass is remains same because the matter contained is same. Correct. But weight is nothing but with what force it is pulled towards the Earth. The force, weight is nothing but a force. That's why it is measured in Newton. The force with which a body is pulled towards gravity is called weight, which changes from place to place. As G value changes, already we discussed it. As the value of G changes, W is equal to mg. The weight also changes. So we'll discuss now one by one about mass and weight, some points here. So you can find huge number of differences. See here, mass is a scalar quantity. It has only magnitude, no direction. Mass of a body does not depends on the shape, size, and state of the body. Mass is same only. So mass of the body is proportional to the quantity of matter contained. Mass of the body can be measured with the help of the common balance. Right? So mass is measured with common balance. It depends on the matter, quantity of matter. It is a scalar quantity. Okay? It is a fundamental quantity also. Now, when you come for the weight of the body is the force with which attracted towards the center of the earth. It is a vector quantity, mathematically given by W is equal to mg. Whereas mass is m is equal to F by A, you can write from Newton's second law. Or you can write from the density definition law. Density is equal to mass by volume. So mass is equal to density into volume also you can write it. So, but weight is given by W is equal to mg. W is weight, m is the mass, g is the, because we are measuring the weight in terms of the gravitational pull. So weight is a vector quantity. Weight is measured by spring balance or weighing machines. Right? The weight of the body is directly proportional to its mass. As mass increases, definitely weight also increases. Okay. So the weight of body changes with the value of g. The weight of the body changes the value of g. That's why weight on Earth is different from weight on Moon or weight on Jupiter or Sun. Okay. So the value of g at poles is highest, that is higher than that of equator. We already seen. So the value of g on the surface is different planets of the solar system is different. The value g decreases with the height from the surface of the Earth. Therefore, weight also decreases. When you go to the height also, your weight decreases. When you go to depth into the also, weight decreases. Okay. So see here, that's where the weight is peak when you go to the Mount Everest. The weight decreases when compared to you are on Delhi, man at Delhi. You are at Delhi, your mass is different. When you go to the height also, your mass will slightly decrease, your weight slightly decreases because of change in G value. Wherever there is a change in the G value, definitely it affects the weight. Right? So we'll see the clearly in the table form so that you can understand clearly. See here, the table form of the difference between the mass and weight. So mass is the simply measure of the amount of matter in a body. So weight is the measure of the amount of force acting on a mass due to acceleration due to gravity. So mass is denoted by M, weight is denoted by W. Okay. So formula, mass is always constant for body, and there are several formulas to calculate the mass. One way to calculate is mass is equal to volume into density. I have seen from the definition of density. So weight is equal to mass into acceleration due to gravity, that is W is equal to mg. So mass is equal to volume into density, density into volume. So here mass is a base quantity, that is fundamental, whereas it is a derived quantity. So mass is only having the magnitude and no direction, scalar quantity. It is a vector quantity. SI unit of mass is kilogram for this Newton. Mass does not depend upon the gravity and is constant everywhere and anywhere in the universe. So wherever you take 1 kg of sugar, its mass remains 1 kg only. But whereas weight depends on the G value, it changes from place to place. Okay. So mass can be easily measured using any ordinary balance, whereas weight requires using the spring balance or formula also. You can measure with the formula if you know the value of mass. So if you know the value of mass, then you can multiply with the G value of that place. Mass into 9.8 or mass into 1.67 or mass into 25 Jupiter, mass into 27.3 Sun. By that you can get the weight of that particular body. Right? So these are the few fundamental or basic differences between the mass and weight here. Very, very important. So this is our synopsis 2 we have done today. So we have 2 more synopsis for the exam. So next class we'll go for synopsis 3, where we'll discuss about some velocities, escape velocity, orbital velocity. Synopsis 4 is there, where we learn about very interesting Kepler's laws of planetary motion. It's about the planets. He proposed 2 laws, Kepler, right? Johannes Kepler, famous scientist. So with that, we can finish up this chapter for the examination on test 6 exam. All 4 synopsis, right? So far we completed only 50% of the gravitation. Remaining 50% will continue in the next week classes, right? So here today we have very interesting topics about the mass and weight. Got it or not? So that's all for today. So this is your home task. Very, very important differences, even helpful for you in your regular syllabus also. Differentiate between mass and weight. So write in tabular form, and you can watch the video, recorded video again and again through YouTube also, to know more and more, to recall the topics during the examinations, right? So note the question, write answer tabular form, and take the correction from your teachers and parents. So thank you very much, students. Have a wonderful weekend. Have a wonderful day. Thank you.